Learning objectives. At the end of this topic, you will be able to explain the process of extraction and refining of metals, define and explain corrosion, analyze the preventive measures of corrosion. Introduction. Meena and her grandmother went for a walk. You've learnt about the reactivity series of metals. Having this knowledge, you can easily understand how a metal is extracted from its ore.
Okay, Grandma.
The Earth's crust is the major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. The elements or compounds which occur naturally in the Earth's crust are known as minerals. At some places, minerals contain a very high percentage of a particular metal, and the metal can be profitably extracted from it. These minerals are called ores. Let me tell you in detail. Let's know about the extraction of metals. Some metals are found on the Earth's crust in a free state. Some are found in the form of their compounds. The metals in the bottom of the activity series are the least reactive. They are often found in a free state. For example, gold, silver, platinum, and copper are found in free state. Copper and silver are also found in combined state as their sulfide or oxide ores. The metals at the top of the activity series, K, Na, Ca, Mg, and Al, are so reactive that they are never found in nature as free elements. The metals in the middle of the activity series, Zn, Fe, Pb, etc., are moderately reactive. They are found in the Earth's crust mainly as oxides, sulfides, or carbonates. You will find that the ores of many metals are oxides. This is because oxygen is a very reactive element and is very abundant on Earth. Thus, on the basis of reactivity, we can group the metals into three categories. 1. Metals of low reactivity. 2. Metals of medium reactivity. 3. Metals of high reactivity. Different techniques are to be used for obtaining metals falling in each category. Several steps are involved in the extraction of pure metal from ores. Let's understand what is meant by the enrichment of ores. Ores mined from the Earth are usually contaminated with large amounts of impurities such as soil, sand, etc., called gangue. The impurities must be removed from the ore prior to the extraction of the metal. The processes used for removing the gangue from the ore are based on differences between physical or chemical properties of the gangue and the ore. Different separation techniques are accordingly employed. Let's know about extracting metals low in the activity series. We've seen that metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar, HGS, is an ore of mercury. When it's heated in air, it's first converted into mercuric oxide, HgO. Mercuric oxide is then reduced to mercury on further heating. Similarly, copper, which is found as Cu2S in nature, can be obtained from its ore by just heating in air. Let's now understand how to extract metals in the middle of the activity series. We know that the metals in the middle of the activity series, such as iron, zinc, lead, copper, etc., are moderately reactive. These are usually present as sulfides or carbonates in nature. It's easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. The chemical reaction that takes place during roasting and calcination of zinc ores can be shown. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. For example, when zinc oxide is heated with carbon, it's reduced to metallic zinc. Besides using carbon, coke, to reduce metal oxides to metal, sometimes displacement reactions can also be used. The highly reactive metals, such as sodium, calcium, aluminum, etc., are used as reducing agents because they can displace metals of lower reactivity from their compounds. For example, when manganese dioxide is heated with aluminum powder. These displacement reactions are highly exothermic. The amount of heat evolved is so large that the metals are produced in molten state. In fact, the reaction of iron 3 oxide, Fe2O3, with aluminum is used to join railway tracks or cracked machine parts. This reaction is known as thermit reaction. Extracting metals towards the top of the activity series. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminum, etc. to their respective metals. This is because these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. For example, sodium, magnesium, and calcium are obtained by the electrolysis of their molten chlorides. The metals are deposited at the cathode, the negatively charged electrode, whereas chlorine is liberated at the anode, the positively charged electrode. Refining of metals. The metals produced by various reduction processes described above are not very pure. They contain impurities which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. Many metals, such as copper, zinc, tin, nickel, silver, gold, etc., are refined electrolytically. In this process, the impure metal is made the anode, and a thin strip of pure metal is made the cathode. A solution of the metal salt is used as an electrolyte. The apparatus is set up as shown. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as the anode mud. We have learnt about corrosion. We have learned that silver articles become black after some time when exposed to air. This is because it reacts with sulfur in the air to form a coating of silver sulfide. Copper reacts with moist carbon dioxide in the air and slowly loses its shiny brown surface and gains a green coat. This green substance is copper carbonate. Iron, when exposed to moist air for a long time, acquires a coating of a brown flaky substance called rust. Let's find out the conditions under which iron rusts with the help of an activity. Take 3 test tubes and place clean iron nails in each of them. Label these test tubes A, B, and C, pour some water in test tube A, and cork it. Pour boiled distilled water in test tube B, add about 1 ml of oil, and cork it. The oil will float in water and prevent air from dissolving in water. Put some anhydrous calcium chloride in test tube C and cork it. Anhydrous calcium chloride will absorb the moisture, if any, from the air. Leave these test tubes for a few days and then observe. We can observe that iron nails rust in test tube A, but they do not rust in test tubes B and C. In test tube A, the nails are exposed to both air and water. In test tube B, the nails are exposed only to water, and nails in test tube C are exposed to dry air. Prevention of corrosion. The rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, anodizing, or making alloys. Galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. The galvanized article is protected against rusting even if the zinc coating is broken. Alloying is a very good method of improving the properties of a metal. We can get the desired properties by this method. For example, iron is the most widely used metal, but it's never used in its pure state. This is because pure iron is very soft and stretches easily when hot. But if it's mixed with a small amount of carbon, about 0.05%, it becomes hard and strong. When iron is mixed with nickel and chromium, we get stainless steel, which is hard and does not rust. If one of the metal is mercury, then the alloy is known as an amalgam. The electrical conductivity and melting point of an alloy is less than that of pure metals. For example, brass, an alloy of copper and zinc, Cu and Zn, and bronze, an alloy of copper and tin, Cu and Sn, are not good conductors of electricity, whereas copper is used for making electrical circuits. Solder, an alloy of lead and tin, Pb and Sn, has a low melting point and is used for welding electrical wires together. Summary. Let's summarize the topic. Today, we've learned that metals at the top of the activity series are never found in nature as free elements. Carbonate ores changed into oxides by heating in limited air. Sulfide ores are converted into oxides by heating in the presence of excess air. Alloying is a good technique of improving the properties of a metal.